Good evening. Hi, I'm Donna Katchmar. I'm an RDA Program Committee member, and I'm on the organizing committee for this series, along with Lonnie Hugaboom. And on behalf of the Rice Design Alliance, I want to welcome you to the first lecture in our fall series, A Material World. We want to thank the Rice School of Architecture and Dean Sarah Whiting for their continued support of our organization and mission. We are also grateful to the Museum of Fine Arts for the use of this wonderful auditorium, and we want to thank them for their continued support of our programs. I also want to thank our sponsors for tonight's lecture. Please see this slide for the complete list. This is also a great time to ask you, as a courtesy to our speaker, to please silence your cell phones and to not use flash photography. Along with our sponsors for tonight's lecture, I want to thank Spall Maxwell Company for tonight's pre-lecture reception. In addition to sponsoring that wonderful pre-lecture event, we will also have a brief book signing after the lecture just outside the auditorium, where our speaker's publication, Transmaterial, will be on sale. Before we begin tonight's program, I'd like to tell you about the upcoming schedule. Please join us next week for Gail Peter Borden's lecture, and note the full lecture series schedule on the slide. On November 13th, our annual Gala fundraising event will honor longtime Harris County engineer Art Story. For more information on all of our future programs, please see our website at www.ricedesignalliance.org. And now I'd like to introduce our speaker tonight, Blaine Brownell. Blaine Brownell is an architect, author, educator, and former Fulbright scholar. He earned a BA in architecture with a certificate in Eastern Asian Studies at Princeton University in 1992, and a Master in Architecture from Rice University in 1998. You always have to be thankful when they put down their dates and give you some clues. He worked also for Young Ho Chang, for Kirksey, for Willis Bricker and Kennedy, and for MBBJ, before establishing the design research practice Trans Studio, which focuses on disruptive material applications and emergent environmental building strategies. Brownell is considered one of the preeminent scholars of advanced materials for architecture and design, and has authored the Transmaterials series with Princeton Architectural Press, in addition to an online material catalog that has been likened to a 21st century version of the Grammar of Ornament. Brownell has been widely published in over 40 design, business, and science journals, and has lectured widely in North America, Europe, and Asia. He was selected for a 40 Under 40 award by Building Design and Construction magazine in 2006, and his book, Transmaterial, was nominated for an International Book Award by the Royal Institute of British Architects in 2007. Brownell was a visiting research fellow at the Tokyo University of Science as a Fulbright recipient, 2006 to 2007, and a visiting professor of sustainable design at the University of Michigan. He is currently an assistant professor and director of the Master of Science program in Sustainable Design at the University of Minnesota. Please join me in welcoming Blaine Brownell.
Thank you so much. And I'd really like to thank RDA and Rice, the University of Houston, and all of the practices represented here. It's really a pleasure to be home. And to give you an example of the degree to which that's true, last night after dinner, after the flight and dinner, driving along Westheimer, I had a strong urge to go home, which is strange when you don't live there anymore. But it's really nice to be back. And this weather, it's always like this, right? Because the trees are near peak in Minnesota. So no, it's wonderful to be back, and I've had a gracious welcome. I really appreciate it. And I should mention too that this is where my research trajectory really began. I had inklings of it while I was in Houston, and then it formed more structure later in my career. But it was really working with Mark Womble and Will Kennedy after graduating from Rice, and they put me on I was working on the Jones Plaza renovation project, and they said, we want you to do materials research, and it's going to be tough, but we think you can do it, and we want you to do this. And I really didn't have much training in this area before, but it was through that project that I learned a lot, and I also learned a lot about how we can improve in terms of our knowledge about materials and also what's out there. So with that, I'd like to look forward, because as the first talk of your lecture series on materials, I think that it's probably most appropriate to try to set a broad theme and to try to look ahead. And sometimes it helps during these economic times to look or take the long view, if you will. So this is a slide. This is a slide of statistics set 50 years into the future. So this is a slide that I presented to my students. So your age, my age would not be 75, 50 years into the future, but my students, at least the ones I presented this to. And it gives a little bit of demographic information. We don't usually think 5 decades into the future, right? I think we focus a little bit more on the near future. So the statistics, I'll let you read this, but statistics are, okay, kind of interesting, and the sources range from fairly dependable to and they get more and more whimsical, I think, as you get down to the bottom, especially. And who knows, right? But I think it's really interesting to position ourselves here, because as we talk about architecture's future, the future of our physical environment, the future of materials use, there are environmental clues in here. There are social demographic clues. Now, of course, this could be inaccurate in a lot of ways, but it's interesting to think about, isn't it? Now, what's especially interesting, though, is to note the degree to which, and again, reflecting back when I was here as a student, the degree to which environmental, social, and technological change has happened recently, and there are certain milestones that are fairly significant that we can think about. The first is that we live in an urban planet for the first time in human history. Right? The United Nations declared this symbolic time or milestone in 2007, and it's an interesting one. We have an increasingly urban demographic, and this, of course, is Tokyo, and I had the pleasure of living right here for a year, which was another transformative experience. But it's really interesting when we think about material resources. Right, because we're talking about more interconnected, dense, complex infrastructure, services, resource consumption from the hinterland, etc. Now, even at home, so to speak, this is a picture of New York, but we could really pick any American metropolis for this point, is that there were projections as late as, I think, 2006, something like that, and of course things changed with the recession, but projections that the U.S. would increase its volume of building by more than half, or almost half, I should say about half, by 2030. Now, this is a little bit debatable at this point, but I think there's still some bold projections of building growth, not just abroad, not just in developing countries, but here at home, which is a little startling to think about. Now, a less tangible milestone, but I think one that we can speak about in terms of popular consciousness, in terms of how our awareness or thinking about nature has changed, is one where humanity has become much more aware of our role, let's say, or our influence on nature. I think really importantly, though, it speaks to, if you think about the deep within the sort of development of history, or through history, the kind of thinking about nature, humanity has often positioned itself, especially in the West, as being gradually or increasingly separate from nature, right? Nature is the kind of other place, the wild, the wilderness, and this idea that nature is a kind of untouched, untarnished space. And we talk about architecture and development like the machine and the garden, or as Kevin Kelly talks about, the made and the born, right? The synthetic, the natural. But gradually we're becoming more, we realize more that those worlds are blurring and that we affect nature deeply. Even if we set aside land for reserve or something, we manage, manipulate, filter, and affect nature. And at the same time, it affects us, right? If our fingerprint is increasingly on it, it reminds us of its own fingerprint. And this isn't just, I want to make the case and connect to the earlier slides, this isn't just global warming and its potential effects. It also has to do with the fact that we have more people living in more populated pockets of space. And unfortunately, as Shigeru Ban, the architect from Japan, reminds us, earthquakes don't kill people, buildings do. Which is, it's both a challenge and an opportunity, right, for architects and contractors and engineers, et cetera, to ensure that our physical environment is able to withstand, is able to accommodate these increasing volumes of people with more resources, but also able to withstand natural disasters. And in terms of thinking about resources, we live in a really interesting, precarious time, and I think that we all know this from a non-renewable resource point of view, but it's still a little bit intangible. These are big forces, big sources of material, fossil fuels, and certain minerals that we've come to know and use in buildings a lot, copper, tin, lead, etc., and even fresh water as a resource. We really, industry and agriculture, have really tapped deeply into these materials as sources. And there's a question about whether, and this isn't the end here, but there's a question about whether that peaking, and it's really an economic peaking in terms of the ability to continue to mine these resources, will really shape this generation and shape this time in humanity's development. At the same time, though, it's not all gloom and doom. This is really what drives me, anyway, is the awareness of and excitement, I think, that new materials, new products, new building systems really can give. And I think that, it's clear with this lecture series, I think the way that architects have transformed to some degree how they think about materials, how the LEED Green Building program has transformed how architects and others think about materials, et cetera. There's a lot of change that's happened. We can think about, just for proof, it would be interesting to look at design and architectural magazines or catalogs of materials, and we would see more change than in previous decades, right? Unprecedented change, because everyone's sort of retooling to get the right green material to market. And we've also seen a kind of explosion in the number of materials that are being offered. So it's a really exciting time to be in the design field, economy notwithstanding. And it's also an exciting time to be thinking about sustainability. And what's interesting is I remember a conversation with Alex Steffen, who founded World Changing and wrote the book World Changing in Seattle, in I believe it was 2005, 2006 or something. And he said, we've crossed a threshold. At that time, or before that time, environmental advocates were screaming to be heard. But after that time, they were being asked, what do we do? And I don't know exactly when that happened, right? But we know that. We know that, this is the given now. We know that at least for a while, too, in the last few years, any news media publication had a story about green design or sustainability at some point during the year, if not every issue. Right? It's really incredible. Now, of course, there are downsides to this, so-called greenwashing. If companies try to, just purely for economic gain, try to get on the bandwagon, so to speak, and sell old products that aren't so green as being green and mislabel things. And we know about that. But I think by and large, people intend to do the right thing and to be responsible in design and other fields. So it gives us ammunition, or the ability to, I think, do good and do good design if done right. So I'd like to talk too about some other influences that are in dialogue with one another, let's say, and which also indicate transformation. So one, we're on this precipice between the so-called hydrocarbon era and the carbohydrate era. Okay, as petroleum and fossil fuels began to become more scarce, and so-called peak oil, I'm not sure when exactly that's going to happen, but it's a non-renewable resource. So when that happens, and preferably beforehand, more renewable resources will be tapped for things like energy to replace non-renewables. At the same time, though, we have increasing competition, right, for those renewable resources. And we saw this happen a few years ago, where the interests of the energy sector are starting to conflict with the interests of getting food, distributing food to countries that need that food, and also medicines, building products, etc. So we have an interesting global social dilemma to work through, right? How to use these resources for more things, and also how to think about resources in terms of full life cycle. We know about the need to recycle and reuse, etc. But it's interesting that design, thinking about design, even as an endeavor that has for a while, for many decades, sought or advocated the kind of search for its own obsolescence, right? Thinking about, let's say, Detroit back in the heyday, when the next year's model car came out, the design was really positioned to make the older model look old. And it's interesting, right? It's kind of engineered obsolescence in design that celebrates or fetishizes the new thing, and we still do this. I do this, but where does this go when we're done with it, right? It still has a life, and how can we? And there are not only social implications, human health implications about that, but also implications in terms of the materials. The materials are becoming increasingly valuable, right? And our awareness of that has changed. So on that note, I'd like to compare, this is a non-technical comparison, if you will. This is a symbolic comparison. Two graphs, or two trajectories, if you will. So this is Hubbard's curve. Hubbard predicted peak oil in America in 1970. But really think about this as the bell curve that tracks a non-renewable resource in terms of its exploitation. And then this is Moore's law. You know about this one too. It tracks, or kind of acceleration of computer technology over time, computer processing speed. And again, it's kind of amazing, right? It gets faster and faster, and it starts to approach a line, which is exciting. It leads to an exciting but uncertain future. But at the same time, we might generalize and say, okay, this isn't just about computers. This is about technology, by and large, right? And its aspirations, its ambitions, its hunger, if you will. And I think this will be one of the most interesting conversations, again, it's a symbolic conversation, that will play out in the next few decades. In particular, as non-renewable resources, which we've used in full force since the Industrial Revolution, began to come in conflict, perhaps, with technology's demand. Not that this is an end game. I mean, not that this is it, right? Because we have other resources. But this will be an interesting dialogue. Now, having said that, I'd like to shift to see how several new families of technology, some materials I've been tracking, products I've been tracking, could play a strategic role in disrupting, let's see, the status quo. So what could those be? And you can tell I'm trying to group a number of technologies together to make a point in terms of a theme. And so this, speaking about energy, again, where are we going to get our energy? Well, a number of sources, right? We know that there's no silver bullet, so to speak, but at least if we want to look at building integrated energy, let's say, and specifically at renewable energy, and the thinking is pretty sound, is that if we have more distributed smart grids, as we've been told, as there's a lot of excitement about, more intelligent distributed infrastructure to handle the power, buildings could also become more diverse in terms of their energy harvesting potential. And everything from wind harvesting, solar, so glazing, for example, could not only, and these are products that exist currently, photovol glass used on the solar, the facade with sun exposure. With this photovoltaic, you can barely see here, could replace ceramic fritting one day. It could replace the need to reduce solar gain by integrated photovoltaic that is on the proper facade to gain energy, for example. There's some other versions of that. These small, sphelar is a small spherical cell that can absorb light from all directions, including bounce light. Can be placed in flexible membranes. This is an interesting study in Japan. This is a building, it's actually the facade of a parking garage. Parking garages, as we know, are not usually, sometimes, they're not usually architectural wonders. But this is a wind harvesting facade. So these turbines softly turn in the wind and admittedly aren't as efficient as a giant turbine out in the hinterland, but at the same time do power all the lighting in the building behind, in the shopping mall behind. We have other things like pedestrian generated power, leaves that photovoltaic leaves that absorb sun and wind power, etc. And lighting is becoming increasingly interesting because artificial lighting produces a lot of heat, right? And we need to use artificial lighting, but we should also think about those times during the day when we have free daylight, especially in deep buildings, buildings that don't have ready access to light, that could really use free sunlight. And so there are systems, this is a Swedish one, Parents, that delivers light via fiber optic cables deep into buildings, mirror ducts, they act just like air ducts, but they're clad in highly reflective metal or polymer materials to convey light deep into buildings. Some other things are really interesting too in terms of, I think, light transmission has also been an interesting subject matter for a lot of material developers. So light transmitting concrete, I can still remember sitting at my desk and receiving an email from a friend about this material. It's been around for some years now, but the other amazing thing is there was another version being developed, pixel panels being developed right here in Houston by Bill Price. And so it wasn't just, and this was developed in Hungary, so it wasn't just that someone decided that concrete should transmit light. It was the fact that two, and actually there was three people in other parts of the world were really working at this problem at the same time. I had a colleague who said, but is it concrete anymore? Which is interesting. Also polymer matrices that distribute light passively into shadow, so light starts to behave differently. One of my favorites is transparent alumina oxide ceramics, which are much stronger and more flame resistant than glass. And I think there are many, there's talk of a lot of different materials that might one day replace windows in buildings. Very interesting. And light also as a kind of secondary effect of materials is very interesting because, and it can range in terms of use, in terms of from diurnal to nocturnal cycles, let's say, to add kind of another pattern or texture, wayfinding, to indicate energy harvesting, let's say. But also, what interests me too is this use in emergency egress situations. So a floor which might otherwise look like this, power goes out, can all of a sudden have this additional intelligence Or same thing with these transparent clips that have photoluminescent pigment. It's an interesting idea about how materials can have multiple readings, multiple effects based on their composition. And we think about energy, one trend I should note is quite interesting is biomimicry, which Janine Benyus is well known for, writing her book by that title, in which she says that we can learn a lot from nature and natural processes. The industry term, as many of you know, is that expression, is that we heat, beat, and treat materials. So we put a lot of energy and pressure into material processing. We cook a lot of materials, so to speak. And she says, well, why can't we make materials like spider's web or nacre or other natural examples that are incredibly strong by weight, right? And not made with any heat. It's just biochemically created. And so it's mainly in the realm of nanotechnology primarily now, and scientists really looking to create artificial repositionable adhesives, for example, or synthetic artificial nacre, there's a material at University of Michigan called plastic steel. It's one of these glassy metallic nanomaterials that kind of defy previous definition. Also structural color, the idea of what if we could make materials we didn't have to paint? The color was integrated within the surface. So these are very interesting ideas. In practice, however, and at a scale that we can appreciate maybe more than, let's say, those rarefied examples in the lab, we do see some interesting developments. I mean, this is really early innings, but interesting developments by architects and designers that are looking for alternative sources of energy, right? Or maybe processes that don't require energy. And so this crazy guy, Tokujin Yoshioka, growing chairs out of crystals, for example, and he does have full-size chairs, as well as some of these wallboard materials, these that they bond exothermically, so essentially magnesium oxide and recycled paper and other materials are placed in a vat, and rather than requiring an oven, right, for cooking, rather than requiring pressure, they bond naturally. And this is interesting too. I just shared, my students and I talked about this recently in a seminar. There's a family of materials that manufacturers are interested in growing rather than manufacturing or processing in using traditional methods. Mycobond is a mycological biocomposite, but it's essentially a mushroom-based insulation. And what I love to do is ask architects if they would like a fungus in their wall cavity. And it's currently, I don't know if it's really been installed yet in this capacity. It doesn't have a great R value. But it's interesting that architects are thinking about how can we grow this thing. So they're essentially growing mushrooms with agricultural fibers and waste. It claims is inert, that it doesn't have spores. My samples don't seem to have spores. But very interesting idea, right? Well, how long, what kind of a lead time do you need for this product? We'll start growing it now. Speaking of growing, bioplastics, right? If Dustin Hoffman heard that plastics was the future, when The Graduate came out, we're familiar with that moment. Bioplastics could be the future now, right? I just met with Cargill and their bioplastic that's based on polylactic acid. Like this, there are a lot of PLA-based plastics based on corn and other grains. It's called NGO, and they are off and running. And they supply material to NEC, and we see bioplastic and other manufacturers, we see bioplastic kind of early innings used for things like disposable packaging. Obviously, disposing some bioplastics is fine, right? The idea is that it's fine, it's non-toxic, made from a renewable source, and it decomposes naturally after you're done with it. Obviously, that would be the idea. That could be an interesting outcome, right? Cradle to grave, cradle to cradle. But we see kind of temporary packaging uses. but increasingly we see more sophisticated uses. So this is a microprocessor made from a combination. It's a type of biocomposite made from chicken feathers and soybeans. So I'm thinking, if they can do that, why can't we make building materials out of this stuff? And cell phone casings in Japan, even smart shape memory, cell phones, even some kind of prototype vehicles. And slowly we're seeing bioplastic building components. But it's an interesting way to shift, again, shifting from hydrocarbons to carbohydrates, shifting. But again, there's competition, right? There's competition for agricultural resources. And so manufacturers are looking increasingly to non-edible sources to make bioplastic. And energy is transportation, let's say, is a critical issue when we think about energy. And so we also have to think about how materials are manufactured. Prefabrication is great, but if materials require shipping, especially heavy materials require shipping far distances, we know that that's not ideal. And so we see efforts like Neil Gershenfeld's Fab Labs, a lot of digital fabrication processes, 3D printing. These are pretty well known at this point, at least in schools of architecture and also some offices. But we're also seeing some interesting things in terms of the material effects. So we're seeing, for example, lightweight structural panels that are kind of composite panels that are designed to be digitally manipulated, or at least fabricated with digital tools. So we're seeing products that understand, or at least are designed, to be manipulated with new processes, which is interesting. And even, I have to throw this in there, even the do-it-yourself movement is quite interesting. The fact that, and we see these interesting websites, Hanako, Kuso, a lot of kind of do-it-yourself websites where designers upload their information, their files, and those files can be downloaded near the consumer, by a manufacturer near the consumer, and made quickly and delivered with little transportation. So this is an interesting kind of distributed manufacturing model that's emerging. And again, thinking about energy, embodied energy, and resources, it's amazing to think about how recycling and reuse has come a long way. In fact, I think recycling and reuse really they're not that different. In fact, there's a blur between those things, and we're seeing that. We're looking now with increased definition at the resolution of that graph. What's truly recycled, what's reused, because there are products and materials that are reused in so many different ways now. Very colorful. We see automobile windshields being remade into interesting glass panels. We see household detergent containers being transformed into resilient and attractive countertops. We see waste building glass transformed into concrete panels. And so there's a really interesting effort underway that counters very well with the first kind of recycled materials that were usually always lower quality, downcycled material. Now, even if material is physically downcycled, it could be upcycled functionally, right? So we might use this, we hope, a lot longer than we use a detergent container. At the same time, though, we have, as many of you know, this problem called the monstrous hybrid. And so we have to be careful. This is a nice material that uses reused waste metal shavings within a phenolic resin to make a countertop or a vertical panel. But how do you extract that again? So we have to think about that at the end of life. And it's also exciting to study materials that are really seeking that cutting edge in terms of being stronger, faster, lighter, thinner. Ductile concrete, for example, has made a lot of waves and has had a strong influence. This high-performance concrete that can be incredibly thin, for example. Also, fiber C concrete, which doesn't need. Now, these are reinforced by fiberglass and other small fibers. Materials, carbon fiber, so that in small precast panels, steel isn't required anymore for reinforcing in certain applications. Also fire protection. So these are interesting materials. Now they're typically more expensive, take a lot of development, and a lot of embodied energy, right? So we have to kind of think about the balance there. But the trend is to do more with less, right? So, for example, engineering, just simple engineering of spanning this river with a lot less material. So that in itself is interesting as a trend. But I think even with the materials that we use every day, we can be smarter about form in terms of structure. Now, some of these materials are interesting. They're intended to evoke certain reactions. They're more ornamental, maybe, but some are structural. Some really are about doing more with less, or let's say doing more with the same amount. For example, if this, we understand that certain corrugation profiling, et cetera, does lend increased structural capacity. So if this were a flat sheet of metal, it wouldn't support the same load, right? Or even this glass foamed aluminum. So it's an interesting way, and I tell my students to think about when they're thinking about materials for a project, and this goes for architects in general. Students they have a lot of energy and interest in making fairly sculptural objects where form is a big part of their designs, which is fine. But what's interesting is the extent to which the integration of form and structure can really play to one's advantage, right? Because if there's performance involved, then it really helps justify particular forms, corrugations, profiles, and you can use less material. You can hybridize materials. So we're seeing a lot of interesting, as I mentioned before, the hybrids, composites that behave better than their individual parts, right? So advanced alloy composites, we're familiar with this one probably, in IIT campus maybe is the most visible one. Panelite aluminum honeycomb between layers of plastic or glass. This is interesting. This carbon cast is concrete, precast concrete that's reinforced with carbon fiber. And it can be 1/3 the weight and substance, let's say physical substance, as a conventional steel reinforced panel. Now it's still a new technology, but it's interesting because steel requires topping to prevent it from rust, and it also requires topping for insulation. But carbon fiber doesn't. So these are some interesting changes that could really affect the industry. Whoops. And we're also seeing, this also relates, earlier I talked about natural forces and being ever more mindful of things like seismic events, hurricanes, et cetera, when they do happen. When I studied architecture and structures in school, it was largely talked about as statics. Now we know buildings there are dynamic loads, right? Live loads and loads by natural disasters, wind, et cetera. Largely kind of position our buildings as static. We want them to stay there. We don't want them to move a lot. But what's interesting though is we have to acknowledge they do move, and that sometimes in ways we don't like. And so there are a lot of new materials that acknowledge that and speak to that change. This Victor Lee's bendable concrete at the University of Michigan again defied my colleagues' previous understanding of concrete. You can bend it. This is crazy. It's something like 500 times the moment capacity of conventional concrete. Again, it's because they're very small glass fibers as opposed to conventional rebar, and they can slide independently, which is amazing. This is already installed in some shear walls and high-rises in Tokyo, so it's not such an outlandish material, and could make potentially stronger infrastructure, more resilient infrastructure. We also see interesting advances in shape memory composites that could be deployed one day for emergency relief shelters anytime that you need. And we're hearing a lot about adaptive buildings that respond dynamically to forces, textiles that can absorb bomb blasts, multiple bomb blasts in succession. So it's a really interesting time to see materials that acknowledge dynamic forces, as well as materials that try to improve the environmental scorecard. Right. So I remember studying LEED, trying to understand the leadership in environmental or energy environmental design program by the U.S. Green Building Council, and many of you know that or are accredited. But I remember early 2000s, becoming acquainted with this program and trying to understand, and there are many criteria, as we know, that try to limit off-gassing of materials, right? So carpets and sealants and glues and things that smell bad, cause adverse effects, let's say, in indoor environments. And so there's an effort to reduce those. But what's really interesting is to see new materials that don't just reduce that problem, but they actually reduce other problems. They reduce environmental pollution. So this would be physical, particulate matter, for example. In the case of several of these, TX Active is a concrete you've probably heard about, developed in Italy, which has titanium dioxide that photocatalyzes in the presence of sunlight, photocatalyzes pollution and causes those particles to drop out of the air. They're too heavy. And this is one example that Field Office is developing as a replacement highway barrier. I think this is clever because this highway barrier not only would reduce noise and light pollution, but also air pollution. Wouldn't that make sense? And also materials that self-clean, right? Based on their special coatings, based on microstructure, paints and glasses that could reduce the need for not only the effort, but increased materials, solvents in the future. So I'm going to shift now a little bit. We're getting into the digital territory, if you will, the influence of the computer. And I remember first seeing this type of technology and marveling, thinking, I call this the Photoshop effect, because it's literally like taking, it's a kind of direct application of what's in here and image manipulation and putting it in the physical environment, shaping the physical environment with that. This looks a little bit like early video games, you know. And we see some other interesting effects. We see photo-etched concrete, for example. We see materials that can be printed with elaborate profiling. We see profiling itself. We see materials, this is a ceramic. You use a photograph and you can get a ceramic with a kind of topographic image. And so I think that's all kind of early in the sense of image manipulation and resulting kind of material effect or material manipulation. But what's really interesting is what we're seeing now. When we're seeing the soft stuff get smarter about the hard stuff, so to speak. And so these are prints done by MIT's Media Lab. They're printed objects. And if you can see in this one, this is called a monocoque. It has two materials, or two families of materials. A frame material, quote unquote, the black, and then a skin material, these kind of white and gray patches. And so there's an interesting convergence between, and this performs as a kind of structural artifact, right? As a kind of intelligent artifact. So imagine buildings one day where the structure and the cladding are printed and find or determine the right way to allow for forces to navigate through the building based on kind of deep intelligence in the machine and also how it affects materials. And how we interact with materials. We're seeing more and more interactive or kind of real-time responsive interfaces. And what's interesting, I mean, some of these have curious entertainment value. I actually got to try this, what was nicknamed the Flickr umbrella in Tokyo, that can project images of your account and also maps on rainy days and help you get where you want to go. This is interesting too, interactive games and facades. And this is a little scary. This is a window that detects or projects information related to building occupants who have RFID tags. And so a lot of interesting technologies, some more valuable than others, but I think this is especially interesting. So a firm called The Living in New York developed these small probes they called river glow that indicate water quality in urban waterways. And I think what's interesting about this is the fact that the technology leapfrogs a previous process and makes it more user-friendly and more direct, right? So previously, a water testing agency would come out and they would take samples and go back to a lab, and the process would take weeks, and then the reporting would be direct. But in this case, you could see right away, right, what's happening. I think we'll see, increasingly, we'll see technologies that, it's a little bit like the Prius effect, the Prius dashboard. right? That we can see certain things that otherwise wouldn't be so visible or obvious, that it changes human behavior and how we manage the environment. We can also have materials that respond. They not only tell us what's happening, but they can actually make, or at least try to make a change. So this is another of their prototypes, same for here. This is an interesting, it's called kinetic glass. It's actually not glass. It's a polymer window with these fins. This is just a prototype, obviously. But what's interesting here is that this is a test, an idea about a future window that could breathe in the case of unhealthy levels of certain gases, right? So carbon monoxide, let's say becomes too strong. Not only does the window tell you by starting to move, but it's actually trying to circulate air. This one is even more active. Sonomorph responds to acoustic changes in the environment. This is developed by a designer in Oslo, and I had a chance to see the development of this project last spring. And what's interesting is they're using this in the design of a musical performance hall for the walls. And so a system that was designed to open and close as a kind of, let's say, biomimetic system behaving like tropism that we see in plants for maybe intellectual value, entertainment value. Now they're using to adapt to the acoustics that are desired within a space, which is really interesting. I can't continue without talking about this. I still want to ask the scientists at the Beckman Institute if they had to use red in this as for healing agent here, but so this is a self-healing plastic. We have self-healing concretes now and different composites. A polymer that can release healing agent into micro fissures when they develop, and thus extending the durability of the material. It's a very interesting take on sustainability, right? It's one take that we might not often think of. Often also fabrics that respond. They're supple in normal use, but on impact, let's say for athletes or even the military, they become strong and rigid. So we're seeing smart materials, responsive materials, with a lot of interesting implications. Okay, so now, almost near the end here, I'd like to talk about opportunities. What do we do with this stuff, right? There's a lot of stuff out there. This is just scratching the surface as we know it. What do we do with these things? Many of you are already tackling that now. But these are some really broad opportunities. So again, trying to stay pretty high level. This is the most broad, I think. This is, and I'll try to explain this, okay. What do I mean by retooling? This is a chart. If you haven't seen it, this is the ecological footprint of countries. So roughly, you probably know about footprint. It's based on resource consumption per capita. This is Human Development Index rank. This is a UN variable that rates, it's a little bit more subjective, but it really rates things like death rate and literacy and healthcare system, et cetera. So it's quality of life, okay? So we're here. So great HDI, we could do better still, but great Human Development Index rank, good quality of life. But wow, we're really not doing very well in terms of our footprint, we know that. At the same time, there's some really struggling developing countries, Mozambique, Sierra Leone, et cetera. This is also not sustainable, right? I think we typically think, oh, just get this down, but really this is not good either. And so this is the sweet spot, right? We want to be right here. We're seeing some countries like Japan, Ireland, Slovenia, et cetera, Argentina, but this is a question, is this sustainable? Are these sustainable countries? What are their processes? How do they manage resources? We really want to pull this down here. And I think that this is a tough thing to do, right? We're trying to tackle this. But given the fact that buildings constitute something like 40% of resource or resource impacts, we're involved. We have to lead this. We have to lead this change. So how do we do it? Well, one thing we can do, next time you see a picture of a beautiful Greenfield sustainable project with all new materials, it's fantastic. It sits in the middle of a kind of virgin landscape, and it's all new and all new infrastructure and everything. You could pose this question. Nothing against Greenfield projects, they're great. But it's interesting, right? Because what do we do with all of this? Now, this is Tokyo again for a fact, but what do we do with all this stuff? And you know what we're going to do. We're going to reuse a lot of it. We're going to reuse especially building skeletons, I think how expensive parking garages are, just to get to the pragmatics, to excavate. Think about all the infrastructure. We also have to maintain this stuff, and it's harder. It's a challenge to do adaptive reuse. And in education, it's usually the exception. At least in my experience, it was more the exceptional project rather than here, take a Greenfield site and put your building on it. But that's changing, right? Adaptive reuse is becoming a more prevalent project just because of the economics, the sheer economics and resource, the attributes of resources just being more expensive, more valuable. And so I think our challenge is to make this an even more exciting and radical endeavor, right? We can do this. It doesn't have to be, oh, I have to renovate this building. I mean, it can really be an incredible challenge and opportunity. And I think this is one, we know about this. Obsolescence, energy obsolescence of buildings. I show some tall buildings for effect here, but we know the recladding project has begun, right? If some of these buildings become too expensive in terms of utilities, tenants are going to go elsewhere. And developers are going to say, well, what do I do with these obsolescent windows? I need a redesign. That's a lot of material, right? But it's an opportunity for architects. And I think, I sort of jokingly say, there's gold and then there are surfaces, right? Because these surfaces have largely kept stuff out, right? Kept elements out, while allowing light in. Of course, we know that. But at the same time, these surfaces are things that we've added. If there's something we've added to this earth, and we've added many things, but we've taken material that exists and we've added a lot of surface area. And that's all surface area that we can use, I think, for multiple goals. But let's do this. Let's not make this, as I've heard joked about in architectural practices, another skin job, right? This is an opportunity to rethink building skins, right? And not only rethink them as a technical enterprise, but also what are the social effects, what are the cultural effects, what are the functional effects, and certainly design is part of all those things, right? It's an opportunity, right? If all this material has to be moved in place, let's not just make it another pretty skin. So, what does this mean, convergence? Well, earlier I talked about Kevin Kelly in John Casbarian's studio. He had us read Out of Control. It was on his reading list. And this is kind of part of my time at Rice, again. Huge influence, who, if you haven't read that book, I think it was mid-90s, its central thesis was that the made and the born would ultimately converge. Okay, so the natural and the artificial, so to speak, biological and mechanical would ultimately converge. Wow, it seems like a kind of radical proposition, but we're already seeing it. We're seeing it in genetic manipulation. We're seeing it in biomimetic responses to making things more like natural objects structurally or performance-wise. What does this mean for architecture? What does the kind of Bios Technos project mean for architecture? Does it mean buildings that look like living creatures? We've seen some of those, right? And I'm not disparaging that, but I think that there's something deeper. I think that there's potential in the performance attributes that nature could inform us of. There's potential in the deeper ecological systems knowledge, right? And we're seeing that. We're seeing materials and systems just start to really tap into that. Materials in general, right? It feels to me like a kind of explosion. This is a qualitative graph, though, that doesn't talk about quantity, but it talks about emphasis over time. So if this is probably the most obvious thing, metals in the 60s were hot, right? But we're seeing a more even distribution. We're not only seeing even distribution, we're also seeing a kind of spread, a kind of intense spread of interest in various materials, composites, products, etc. And again, pick up a product catalog today and look at its past iterations, and you'll see more change recently than in the past, typically. This is the last opportunity I'll talk about. There are many, but it's a social one, okay? And I borrowed Global Flattening. I borrowed that from Tom Friedman's books, The World is Flat, Hot, Flat, and Crowded, where he talks about the kind of social phenomenon that new technology have really unleashed, or new technologies have unleashed. And it has to do with the fact that with pervasive internet, access to cell phones, computers, etc., increasingly pervasive, that we now have an increasingly competitive global audience. Now, how do we typically hear about it? It's typically, we hear about it as a negative thing, right? We hear about it as, gosh, call centers taking jobs away. I know I've witnessed this transformation, as many of you have, probably in larger architecture firms, that now a lot more models are made in China, right? Or renderings are made in China, for example. But I want to position this not as a challenge, as an opportunity. This is incredible. This is unprecedented, again, in world history, to have this kind of creative, productive, intelligent workforce. We've never seen this before, right? Think of the diversity. Think of the contribution that this incredibly diverse and creative body of the most important resource, right, for us, the human resource, can contribute to the conversation. And I'd like to see more ways in which we can really make this a positive thing and tap that opportunity. And with that, this is my conclusion, that it really is that resource that has driven my research more than any other. I've been asked, what's your favorite material? What's your top 10? And to me, it's really not about a material in the end, right? It's about the people that tirelessly make this stuff. Don't you love it? This is fantastic. People constantly making, testing, embracing, really the multi-sensory experience that materials bring, asking more out of their projects, saying, why do we have to do it like this? Why have we done it like this? And not to say everything is bad, but the questioning is amazing. I mean, at school, students, when I was in school, the feeling was largely, okay, this is a material, this is how you do it. Okay, that's interesting. You try to absorb all this stuff, this is how it's done. Well, students now can question anything, just about, right? Well, why do we do it this way? Isn't that not sustainable? The ground is fluid, right? But at the same time, there's a real investment of energy. I think that's the important thing, right? Is that students are energized. Young architects and architects of all ages are energized by this and the potential that this brings. And obviously, you have to do a lot more testing. We can't just, just grab anything. In fact, I think that if anything, it requires us to become experts, develop deep expertise in new materials, not necessarily just grab a lot of stuff. But this is really inspirational. And I think that, for me, this is one way that we can accomplish, I hope, we can accomplish, and I think we can, one of my most passionately held goals, which is to prove the value of design. And I think that, and this is an opportunity that a lot of architects have embraced. They've stepped up to the plate, rather than trying to convince clients of, I want this sweeping form. Well, why? Well, just because I'm a sculptor, right? Nothing wrong with sculpture, but when you can make a stronger case for design and what it can do, aesthetically, but also technically. Also, what are its social effects, right? Environmental effects. This is really important. If we can nail that intersection, then design can really be something that's celebrated, and really something that can sell itself, right, as a process. And I'd love to see, I am seeing designers and architects take that leadership and to construct a more responsible, more creative, and much more innovative future physical environment. Thank you. I'd be happy to take some questions. It's a little long. Yes.
I heard on NPR the other day about one of the Nobel Peace, one of the prize winners was for this graphite, this very thin graphite. I don't know if you're familiar with that yet, or if it's been explored for building purposes, but apparently it has a lot of strength.
The question was about the recent Nobel Prize that went to scientists that developed graphene material, which is based on carbons. Carbon, wow, one of the most familiar materials in many different guises, and one of the oldest that humanity's manipulated, and still producing some pretty amazing things. My students and I read the article the morning that it came out, and we're reading things like it's the strongest and thinnest substance on Earth. It's 1 atom thick, and on a pencil point of this can hold up a truck, and it's transparent. So that you can't, people, come on. You believe this stuff? Now, this is under laboratory conditions. A lot of this is, it has been produced, but it's still hypothetical in terms of, well, how do we scale this up? We call this the micron to meter problem. That's a lot of scientists are working on that. Architects are chomping at the bit. When can we get this stuff in a, can you do like 4 by 8? So, there are incredible implications. I don't know, I can't put a timeline on it, but we'll see what happens. Yes?
Do you have any guess as to when thin film photovoltaics will be affordable in the commercial market, building market?
Thin film photovoltaics, when will they be affordable? Isn't it, gosh, I feel so impatient with solar power, don't you? It's always just been right there, but just out of reach. It's hard to predict. I think that, one nice thing about thin film is that it's much more cost effective, or can be more cost effective, but not as powerful, not as efficient as other forms of photovoltaic energy. What's compelling is, and I meet on occasion with the editor of Fabric Architecture, who's based in Minneapolis, and we talk about textiles, artificial textiles. And we're seeing a lot of interesting iterations of solar harvesting textiles, not just for canopies, but for other types of roof systems, etc. But it's still early innings. Too bad. It will take some time. Economists predict that if in fact the kind of balance of energy does shift, that things will, that the situation will make that source of power more attractive. But at the same time, I hear all kinds of interesting stories of new methods of harvesting solar energy that are, many times more efficient in a laboratory condition, but not yet. But one interesting thing I'd like to add, though, is in terms of power harnessing, I'm really interested in integration with materials. If we could make the whole textile, let's say, harness power, the whole window harness power, it's not an add-on, right? That's the tough thing. If you have to, and I want this belt and suspenders. And for example, concrete is a territory of rich exploration, just because it's the second most consumed fluid in the world. Concrete, right? And the fact that it has a lot of global warming potential, contribution, and so there are issues there. People are trying to improve upon it. But I think, so I'm more giving examples of materials that have crossed that threshold, let's say, into mainstream. And I think it does. It often takes manufacturers, designers who see a hole and a reason for improvement, and maybe make some more incremental improvements that are viable, that can come to market. Even the addition of titanium oxide can make, with this photocatalytic concrete, it's more expensive, but it's already being put into place. This new bridge that we have in Minneapolis that replaced the last one that failed has both higher performance concrete in terms of self-healing capability, but also, which is nice, right? But also has some titanium dioxide to clean the air. So it's interesting. Some of the stuff is happening, we don't maybe even know it's happening. So
Maybe one
I'm
more?
not sure who was next. Yes.
Yeah, I don't want to sound like a Luddite or whatever, but this stuff is really exciting, but to me it's very worrisome. Not just, like I heard someone talking about how like every university has a nanotechnology department, but relatively few have like environmental or toxicity chemistry departments. But I think it goes further than that. It's like the psychology of it all is like it takes so much, and I just want to, I think you know what I'm talking about, and I just want to know what you're feeling towards that. You know, instead of, like, I'm always freaked out that in Houston, everybody could just put a black bucket on their roof and have hot water. And we don't do that, you know. Everybody can have that. And instead we're talking about thin layer voltaic cells. And I'm just wondering what your thoughts are on that sort of
Well, I sense at least, yeah, I sense at least two really valid points, and that there are probably more, but valid points in that question. One of which has to do with implications of technology. I mean, this is an issue that has been around probably since the origins of technology. I'm not downplaying it. I'm just saying it's always an issue, right? Marshall McLuhan talked about it. Talked about the importance of the role of the artist, for example. In his view, as always being mindful of the implications. Where are we headed, right? What's happening? Because I think as new technology becomes increasingly adopted, sometimes society does it mindlessly. We don't think. So I think you're absolutely right in terms of thinking about deeper implications. Pragmatically, testing. I think more testing has to be done. How about these houses in Florida that are full of toxic drywall that the owners can't sell from China, right? The sulfur, high content sulfur drywall. So absolutely, we have to do. I mean, that's a pragmatic step. I think there are deeper philosophical questions there as well. And I think there's another question I understood, which has to do with kind of low-tech solutions, right? And this is something I don't know where you really draw the line between low-tech and high-tech, but I'm not an advocate purely of high-tech sensibilities or approaches. In fact, sometimes low-tech approaches can be much better solutions, more cost-effective, and it's really interesting. I mean, and I think part of this biomimicry movement is looking at biomimicry from a process standpoint, from a growth standpoint. That you can grow these materials. That's still a technology we need to study, right? Bricks, you've probably heard about this bio brick that's grown effectively. So, and there's some other interesting versions. So I think, but even low technologies like, can we take some of this agricultural waste and just make a building panel? Something fairly simple. And I think that's great. I mean, that's part of what I see as innovation in general. It's not necessarily something that requires, exotic metals, let's say. So I think, but you're right. I mean, I think it's a good cautionary tale.
All right.
Okay, thank you very much.
Blaine will be signing books outside the auditorium. Didn't know if you wanted to.
No, that's great. I'm glad you did that.
Hey, John. Good to see you. How are you?
Hi, how are you? Yeah, well, we don't know. I can't tell you that until I go through the question and answer because I'm the one that reports what it is talking about. So I think this one will be, and I can't imagine. But I don't
Well, you're working on it.
I'm trying.
Okay, I need to beat my hours.